Okay, so today in the video I'm going to talk about how to simplify inverse trigonometric functions if they have a bizarre looking input, you could say. Obviously the input is going to be not random, it's going to be like a particular formula. Like let's start, right? Then you can understand it on your own. I don't have to elaborate it that much. Okay, let's start now. Okay now, so let's start with this expression. Let's call it I. Let's call this expression I. Let's start with this. Okay, let's say I is equals to tan inverse 3x minus x cube divided by 1 minus 3x square. Let's say that this is the expression that we're trying to simplify. Now I want you to notice that this inside function in x looks like a very common identity of tan 3 theta. Tan 3 theta is equals to 3 tan theta minus tan cube theta divided by 1 minus 3 tan square theta. From this I had a thought of substituting x as tan theta. Now if I do that, this entire thing will become tan 3 theta, and somehow we can cut the tan inverse in tan. So that's my thought process of why I'm going to try and put tan theta here. Okay, so let's put x as tan theta. Now you cannot do this without specifying where theta will lie, right? So for that we need which values of x can I actually put. So basically we have to find the domain of x, the permissible values of x. Now tan inverse poses no constraint whatsoever on the value of the inside thing. Therefore it can be any value. This entire expression can be any value. Therefore this x cube, right? The constraint on x is going to be put by this expression itself. You can clearly see that the denominator cannot be 0. That is the only constraint in this expression. So the value of x is going to be, when the denominator is 0, I'm putting the denominator to be 0 to find the values of x which I cannot put in the expression, basically the points where the expression is not defined. Now the values I'm getting are plus minus 1 by root over 3. Now this value of x, these values of x are the values which are not in the domain. Basically the domain is going to be, if I write the domain of x, or domain of I, I think is going to be a better thing to write, but okay, let's write this x here. Like, you understand what I mean, right? Why am I writing x? So that you can, if you refer to it afterwards, you can actually see what I'm writing. I could have written I, but come on, you understand what I mean. Okay, whatever. The domain is going to be from negative infinity to negative 1 by root 3 union negative 1 by root 3 to 1 by root 3 union 1 by root 3 to infinity. So that is going to be the domain of this, right? Okay. Now I am going to choose my theta so that the values of x like these values of x which I can put are all accessible using the substitution. Now in the next step I would like to do something like this. Tan inverse x is equal to tan inverse of tan theta. I would like to do this, and I would also like that the tan inverse and tan theta cut out. So basically I want this. Now we have to understand that to do this, theta has to belong in the principal range of the respective inverse trigonometric function. Now tan inverse has the principal from negative pi by 2 to positive pi by 2. Both are excluded, then points are excluded here. And another thing that I think you should appreciate is in the principal range, all values are accessible of the corresponding function. So basically tan theta has all real numbers, right? In minus pi by 2 to pi by 2 we can access all those values. Therefore I would like to choose my theta from minus pi by 2 to pi by 2 so that this step is valid, that this cancellation of tan inverse and tan theta is valid. I like to choose my theta from minus pi by 2 to pi by 2, while also keeping in mind that the theta that I'm going to choose will allow me to access all these x values. Now therefore the theta that I'm going to choose, the interval of theta that I'm going to choose is going to be from negative pi by 2 to the tan inverse of this to the tan inverse of this, and this is negative, I think, pi by 6 union negative pi by 6 to pi by 6 union pi by 6 to pi by 2. This is the interval of theta that I'm going to choose, and after this we can very clearly see that, okay, by the way, this step is very this step is valid for all the thetas here because they lie in the principal range. That is one thing that you should keep in mind and not feel conscious about, like, is this step valid or something like that. This step is valid for all values of theta in negative pi by 2 to pi by 2, and we are in reality excluding some values, two values to be specific, the negative 1 by root 3 and positive 1 by root 3. So that therefore the interval that you're choosing is actually the subset of the principal range. So that has to work. If the principal domain works out here, then the subset of that will also work out. Now therefore after this substitution, the I becomes tan inverse 3 tan theta minus tan cube theta divided by 1 minus 3 tan square theta, and that's the actual reason why we even substituted tan theta here, because this thing cleanly becomes 3 theta, the tan 3 theta. This thing is equals to tan 3 theta, and this is valid, right? Okay, now if theta belongs in the interval of this given interval, then 3 theta will belong in the interval. You can write the interval here from negative 3 pi by 2 to negative pi by 2 union negative pi by 2 to pi by 2 union pi by 2 to 3 pi by 2. This is going to be in the interval. Wait a minute, just wait a minute. Okay, I'm back. For you, I was here, right? I had to cut the video for some reason. I'm not going to tell you. Okay, now where was I? Yeah, this is the range of this is the range of the domain of 3 theta. Now you are able to see that we cannot cut this and this. We were able to cut this and that, cancel this, because theta was in the principal domain. But here it is not. Therefore, we have to make cases where each like basically we have to deal with each case separately. The first case is when 3 theta comes like that, this and this cleanly cancels out and gives 3 theta. That will only happen if 3 theta belongs in the principal range, that is negative pi by 2 to pi by 2, and that is in the 3 theta thing. Okay, so this is one of the branch. This is one of the branches. Now if we look a little bit, okay, let me just how can I, okay, wait a minute, okay, just I can do that. Can I do that? Yes, I can. Isn't the entire thing coming in the yep. Now okay, now the remaining parts of the interval, okay, let me write the interval, the entire interval that we are focusing on. Okay, now we have already talked about this branch and this branch are remaining. It may be that we further have to bifurcate these 2 branches into other branches to accommodate the tan inverse breaking, right? Let's talk about that. Okay, now tan inverse tan theta is equals to theta only when the theta belongs in the interval, the principal range from negative pi by 2 to positive pi by 2. Now let's now therefore talk about this. What happens when theta belongs in this interval? What happens to the theta? How does it break open? What happens is we have to make adjustments to this interval such that the inside value doesn't change, but the angle changes and falls in this. Now see, if we add pi to this, now also bear in mind that when we are dealing with this, we want the inside function to be the tan. Now if we add n pi with tan, doesn't matter if it opens with a positive or a negative, it's going to remain the same function. It is valid for all trigonometric functions, not the tan. In case of tan, what happens is n pi plus theta is always equals to tan theta. But in case of, let's say, sine, in case of sine, it is not always sine theta, and sometimes it opens with plus and minus, or minus, not and. Okay, now what I mean is if we add pi, this is pi, to this interval, we see that this interval, wait a minute, okay, this is negative, right? Did I make a mistake somewhere? Okay, if we add pi to this, what happens is the interval shifts to minus pi by 2 to pi by 2, and this is actually the principal range. Therefore, if we can make the inside angle to be the theta, which lies in this, plus pi, then we can directly cancel the tan inverse and tan. Now can we do that? Let's check one thing. If we add theta to pi and calculate the tan of that angle, what does it come out to be? Lucky for us, it comes out to be tan theta. Lucky for us, it comes out to be tan theta itself. Therefore, tan inverse tan theta can be written as tan inverse tan of theta plus pi, and when the theta is belonging in this interval, we have seen that after adding pi, this falls in the principal domain. Therefore, we can directly cut the tan and tan inverse when the theta belongs in this interval, right? And write it as theta plus pi. That is basically the answer in case of this domain. Now, I found out that, so we can now go and now write this here, right? It opens with 3 theta plus pi, but before we're talking about theta, a general angle. Now the theta has taken the role, 3 theta has taken the role of theta here. I hope you're not mixing them up. When the 3 theta belongs in the interval that we had talked about, that is negative 3 pi by 2, no, negative pi by 2. Now the last branch is remaining. We may not have to bifurcate it into further domains so that we can accommodate it, but yeah. Now, okay, the last domain, the last branch is of pi by 2 to 3 pi by 2. On the same line, you can, if we see and observe that if we subtract negative pi from this, we're going to get what, negative pi by 2 to pi by 2, and that is also in the principal range. Now tan of theta minus pi is what is it? This is also tan theta. How? If you take a negative out, you can write it as tan pi minus theta. This is just a method, okay? I have this habit of doing this and then getting the answer. If you know some other method to compute this stuff, very well, do that. You don't have to mimic me. Okay, tan theta, but this comes out with a negative, and this becomes tan theta. Therefore, you can actually, in this interval of pi by 2 to 3 pi by 2, we can open this with the 3 theta minus pi thing, and this is the entire branch. This is the entirety, okay? 3 branches are there. It's a piecewise function. Now obviously we have to go back to the x world, so let's do that. 3 tan inverse x. 3 tan inverse x belongs to minus pi by 2 to pi by 2. 3 tan inverse x. Okay. Now, this can be, you can leave this as it is, but we can write the constraints only in x without involving the tan inverse. Let's do that. It will be a little bit more elegant, right? Let's go to some corner and find that 3 tan inverse x belongs to minus pi by 2 to pi by 2. This implies that tan inverse x belongs in the interval negative pi by 3 to negative pi by 6, positive pi by 6. Now, x will belong in the interval. We can take the tan on both sides. Why? Because if you remember that in negative pi by 2 to pi by 2, the tan is an increasing function, so we can write this, and tan of tan inverse x is always equals to x. We're dealing with tan inverse of tan x. This is not always equals to x. This is only x, and it is in the principal domain. But here in this case, we're talking about tan of tan inverse of x, and that is always x. Obviously, if it is defined in the inverse. Lucky for us, x can be real in this case for tan inverse. Okay. even if we're not lucky, we could have done this. I'm going to talk about some other functions here, but yeah, I'm going to take a little bit more tedious example just after this. Okay. Now, therefore, this is going to, okay, by the way, this is not ITF, this is not inverse trigonometric anything, this is your algebra, right? This is just solving inequalities and all that. Do it however you like, right? Do it however you like, doesn't matter, you don't have to mimic me. Therefore, this is going to belong in the interval of this, and I can write it here. Now let's take this tan inverse x, dividing by 3, we're going to get negative pi by 2 to, what is this, 3 pi by 2, right? Wait, what is this? This is pi by 2, what I'm doing, negative pi by 2, okay. Negative pi by 6. X is going to belong in the negative infinity to negative 1 by root 3. X is going to belong in the interval of this, and you can directly write that this is going to be from this, because initially x was having the proposed domain of the union of these branches. If we have written this and this, we can subtract these two from that and find this is going to be the domain. But let's not, like, if you're here, then let's just find it. I'll leave it at this. So 3 tan inverse x is going to belong in the interval negative positive pi by 2, 3 pi by 2, you know how it goes, you know. Therefore, x will belong in the interval, or this implies is a better thing to write. X will belong in the interval of 1 by root 3 to infinity. Okay. Therefore, basically, tan inverse 3x by x cube divided by 1 minus 3x square is equals to 3 tan inverse x when x belongs in the interval negative root 3 to root 3, and 3 tan inverse x plus pi when x belongs in the interval negative infinity to negative 1 by root 3, and 3 tan inverse x minus pi when x belongs in the interval 1 by root 3 to infinity. This is the entire definition of this function upon simplification. Now, you might have seen people do a lot of things, like not so rigorous things, right? Everything here was rigorous. You might have seen just the people just substitute x to be tan theta, then they say the tan inverse tan 3 theta, I can just cut this and write it as 3 theta, then plug the value from here to here as 3 tan theta. So 3 tan inverse theta, 3 tan inverse x, and they equate this and this. Completely wrong. This will lead to wrong answers if x belongs to these intervals and not this. So I hope you have followed till now, and okay, we're going to talk about another function. This is going to be, I think, very beneficial for you, because I will talk about some more minute intricacies. And yeah, let's start. Let me just get margin in. You don't have to see the margin. Okay, let's not waste page. Okay, this is the margin. Okay. The next expression that we're going to try to simplify is going to be in the form of like this: 2x root over 1 minus x squared. Why did I take this expression? I'll give you some time. You can even pause and ponder that. Why did I take this expression? Okay, I gave you time. You might have paused and guessed what I'm trying to do here. You see, if you put x to be sine theta here, you're going to get x sine theta, so 2 sine theta multiplied by the root over 1 minus sine square theta, that is root over cos square theta. That is, If we get rid of all constants and just like for roughness, nothing else, roughness is going to be cos theta, has to be mod of cos theta. I'm going to talk about how to deal with that. As I have told you, I'm going to be very rigorous in every step. And here if see, if you write cos theta, here is going to be sine 2 theta, and sine inverse of that roughly you can write somewhere 2 theta. Therefore you can simplify it using this substitution. Then that's what I have thought, and that's why I am going to substitute this to be sine theta. Now can I, that is the question, can I do that? Because remember, sine theta, even if you have the right to put any value of theta from negative infinity to infinity, any value, the sign of that value is always going to be constrained in a very minute interval, that is negative 1 to 1, because sine theta belongs in that interval. But x could be 50, or can it be? That's why we're going to find the domain of x. Now in each, first of all, this x has to be greater than or equal to 0, and this thing has to be greater than or equal to 0. Upon solving, okay, if you don't know how to solve, you can learn how to solve inequalities. Obviously this is algebra. If you're not able to do this, if you're not comfortable doing algebra, you're going to get like even if your thinking is good, you're going to feel short at some point in time in whatever you're doing, because algebra comes into play everywhere, right? Everywhere algebra comes into play. This is algebra. Algebra is very important. I think you should know how to solve inequalities, basic inequalities like of quadratics, cubics, or how to approach inequalities. I'm going to just talk about how to do it. Okay, see, if the thing is, if you know how to solve, we can just say that the x is going to belong in the interval negative 1 to 1, but I'm going to explain to you everything. So yeah, first of all, factorize this expression, whatever the expression is, then plot the critical points. Now critical point is just a term. Now I can just say plot the critical points. Now critical points could mean the points, or you, okay, where you drop your p while p, what is the definition of critical points? That's why I don't like definitions of everything. Like everything is just, people just try to complicate stuff using definitions and all that, whatever. But yeah, let's not go into that. The critical points here mean the zeros of the factors. This is going to be 0 at 1, this is going to be 0 at minus 1. Plot them. Now the thing is, you have to check if the value is more than 1, is this value going to be positive or negative? Now if the value is more than 1, this is going to be positive, and if the value is more than 1, you can clearly see this is going to be negative. Therefore after 1, the value is going to be negative. Okay, let me see if it is visible. Yeah, what the fuck is happening? Okay, and between negative 1 and 1, if you clearly see, it's going, this thing is going to be negative, or is it going to be negative? No, sorry, this is going to be positive in negative 1 to 1, but this thing is going to be negative, right? Right? Or am I mistaken? Okay, sorry, both of them are going to be positive actually. This and this are both going to be positive in negative 1 to 1. This is going to be positive. Now if it is less than 1, minus 1, this is going to be negative, and this is also going to be, sorry, this is going to be positive, right? Therefore this entire thing will become negative. Now we wanted the interval where we wanted the solution set where this was greater than or equal to. Therefore, from this we can conclude that the answer is going to be from x is going to belong in the interval -1 to 1. Why these are included? Because equal to sign was here. And how do I know that at x equal to -1 and 1 this is going to be valid? Because these are the points where the expression was 0. That's how we even plotted this at the first place. In the first place, this is going to be the solution and this is going to be the domain. So I can write now. Domain of x is going to be equals to -1 to 1, and this corresponds to the trigonometric function of sine theta, cos theta. But you cannot, now here the thing is, you cannot, even if you wanted to, you cannot substitute the values. You cannot substitute x to cosec theta, because cosec theta's value is from -infinity to -1 union 1 to infinity. Therefore you can get only one value, not the entire domain. But you can put it to tan theta, you can put it to cot theta, because they belong in the real world, real numbers, and the subset of that is -1 to 1, both included. And if it is subset, then obviously you can take it, right? Like R is very large, the subset is -1 to 1, you can just constrain the theta values for that matter to get the correct domain. Okay, therefore we can put theta to be sine theta in, because we can actually get all the values. Now if you put x equal to sine theta, obviously the domain that I'm going to take is going to be the principal domain, so that I can, do this, do what, do this and write this. Okay, it's not showing, but this, I can cut this in this domain. Now therefore I is equals to sine inverse 2 sine theta root over 1 minus 2 square theta. Okay, 2 sine theta. Now this is going to be cos square theta, right? 1 minus sine square theta is cos square theta, and the root over cos square theta is going to be mod cos theta. So let's just write it as mod cos theta. Now theta we know belongs in the interval -π/2 to π/2. Now if you don't know trigonometry, then I cannot help you, because this will make the video very large to go from that basics. In this interval, the cos theta is positive always. Therefore, since in theta belonging to -π/2 to π/2, cos theta is greater than equal to 0, this implies mod cos theta is going to open as cos theta. I can write this as 2 sine theta cos theta, and this we know is equal to sine 2 theta, and 2 theta now will be having the range -π to π, right? Okay, I hope you're with me till now. Okay, now we're going to do the same exact thing that we had done before. Let me just go to some other space and write stuff here. This is the margin that I was talking about. We're writing here. Okay, forget about this. So sine inverse sine 2 theta, 2 theta belongs in the interval -π to π. Now this is equals to 2 theta. If 2 theta belongs in the principal range, that is this, some more range, some part is remaining. Let's talk about that. Now -π to π, right? We took out this part, so what is remaining? If you subtract this from that, you're going to be left with -π -π/2. You can include or exclude it, doesn't really matter, because you're going to get the same answer. Let's just include it. Okay, you can put the value and check. I'm not going to go into that. Okay, and this these two branches are remaining. Okay, now clearly if you add pi, you're going to get 0 to pi by 2. That's a principal range. That's in the principal. The principal range was negative pi by 2 to pi by 2. This is the subset of this. Therefore, we have already talked about that in the previous case, how to get definitions from this. Therefore, now also let's check that theta plus pi actually gives us the correct thing or not. And we get sine theta, and we get a negative sine theta. Okay, that's good. Now how can we get the correct answer? Because sine inverse sine 2 theta, or theta, let's talk about, is not equal to writing theta plus pi. So we cannot cut. We can cut, but these and these are not equal. So what can you do? You can see 0 to pi by 2, right? If you take the negative, it's going to be negative pi by 2 to 0. That's still in the principal range. Yes. And therefore, if I instead of writing this, I write negative of this, we know that the negative angle, this will come out and be like this. And this was the negative of sine theta. Negative and negative will become positive. Therefore, this is equals to negative of sine theta plus pi, and we can take the negative inside, negative theta, negative pi, right? And this and that we cancel, you're going to get negative theta, negative pi. Therefore, a definition of this is going to be negative 2 theta, negative pi, if 2 theta belongs in the interval negative pi to pi by 2. Similarly, the last branch is remaining. We may not have to bifurcate it. Most probably we do not have to bifurcate it. How do I know? Because I've done this question and it's very symmetric, Okay. So pi by 2 to pi. If you subtract minus pi, you're going to get negative pi by 2 to 0. A similar thing. Let's check. Theta minus pi is minus of negative pi by 2. Look at this, whatever. Negative theta, therefore let's take the negative of this, sine of my minus theta. Therefore this is going to open with, this is negative, okay? Negative 2 theta plus pi when this lies in this interval. Okay. Now therefore this thing is, okay, this is the entire definition. Therefore you can write it as 2 sine inverse x, theta was equals to sine inverse x. That's how we initially chose the domain of x for the 2 sine inverse x belonging to negative pi by 2 to pi by 2, and minus 2 sine inverse x minus pi when the 2 sine inverse x belong to an interval, and negative this. Okay, what was the domain or the range or whatever the fuck it was? I want to end the video, man. What was the domain, man? Negative pi to negative pi by 2 and pi by 2 to pi. Now you can leave it at this, but you can still find the x values. Therefore you can equate it to 2 sine inverse x. Solve this yourself and you can see that x is going to belong, x is going to belong in the interval negative 1 to 1. This one, 2 sine inverse x minus pi, x is going to belong in the interval. Wait a minute. Oh my god, this is 2 sine inverse x. If we take the 2 here, is going to be minus pi by 2 to plus pi by 2. This is going to be 1 by root 2 and this is going to be positive 1 by root 2. Okay, and this is going to be negative 1 to negative 1 by root 2, and this is going to be this thing. Therefore, the entire definition comes out to be of sine inverse 2x root over 1 minus x squared equals to 2 sine inverse x. X belongs in the interval -1 to -1 by root 2. Then, sorry man, -1 by root 2 to +1 by root 2. And okay, I cannot speak more. I really want to end the video. Hope you have understood everything. And this is the definition. I hope you were able to understand the thought process of what to do and how to branch stuff, right? I'll see you in the next video, and I think up to this everything is clear. I will try to make another video about this topic. I'm going to take some more examples. I'm going to do them obviously faster because I've already explained the thought process in the upcoming videos. If I make more videos, I'm going to do them a little bit more faster because I have already told. Fuck it, I'm saying the same thing hundreds of times. Fuck it, man. Bye, guys. If I make another video, see that video. If you don't wanna, then don't mostly. You're gonna. That's fine. Okay, bye, guys.